Suppose that phi is a homomorphism from U15 to itself, and the kernel consists of the elements 1 and 11. By the way, remember kernels are subgroups. So that should be a subgroup if this is going to be a valid kind of problem. And you can double check in your mind here, do calculation in your head. 11 has order 2, 11 squared is 121. 121 mod 15 is 1 because 15 does divide evenly into 120. You're told phi of 7 is 8. Find all the elements of U15 that map to 8. This seems like, I think, a hard problem. Like, what in the world? How in the world can you possibly do this? This problem is based on knowing a fundamental fact about homomorphisms. It's in theorem 10.11 or 10.1, excuse me. It's property 6. Pretty important property, actually. If phi of g equals g prime, then this is called the preimage of g prime. Remember, homomorphisms don't have to be one-to-one. So the inverse function of phi need not exist. But this notation is still used. It's called the preimage. We've talked about that before. It's everything in G that gets mapped to G prime. And this theorem says it equals this coset of the kernel. And that's relevant for this problem, because in this problem, phi of 7 equals 8, we're trying to really find, well, if we're trying to find everything that maps to 8, so we're trying to find the preimage of 8. By the theorem 10.1 part 6, the preimage of not 7, but 8. This is not a one element. This is more than one element. This is a set. According to this theorem, it's the coset 7 cur phi in the theorem. So phi of 7 equals 8. The 7 is playing the role of the G, and the 8 is playing the role of the G prime. That's supposed to be a G there. The 7 is playing the role of the G, and the 8 is playing the role of the G prime. The preimage of 8, everything that is in the domain, which, by the way, the domain and codomain are both the same here. They're both U15. Everything in the domain that gets mapped to 8 is this coset. Since you're told the kernel is 1, 11, you have to compute this coset. 7 times 1 is 7. 7 times 11 is 77, but mod by 15, what would that be? 2? 77 mod 15 would be 2. There's the answer. 7 and 2 are the elements that map to 8. Okay. Notice this is not a subgroup. Doesn't contain 1 for one thing. It's not a subgroup of U15. Cosets in general are not subgroups. They're only subgroups when they equal the original subgroup. AH equals H if and only if A is in H. So the coset is only going to be equal to H and only going to be a subgroup, in fact, if the representative is already in H. Otherwise, it's not going to be a subgroup.